Welcome to our YouTube channel students, e-learning hub by Udgam Welfare Foundation. Students, in this video series we are going to discuss about the case studies on application of integrals, and these case studies are useful for every student, whether you are a CBSE board student or an ISC board student. In this case studies we are going to discuss different concepts related to application of integral. Now let's move and discuss our first case study on this particular chapter. So students, here comes our first case study on application of integral, which states Shivani is an architecture student who is working on designing a unique garden layout for a school campus. The boundary of the garden on one side follows the parabolic curve given by y is equal to x square, while a decorative fence runs along the line y is equal to 4, which acts as a horizontal limit to the garden space. Shivani wants to calculate the exact area enclosed between the curve and the line. To help her order the correct amount of grass turf for landscaping, she decides to use the concept of definite integration to determine the area between these two curves. The points of intersection will define the limits of integration. This practical application demonstrates how integration is used in architectural and civil engineering designs to estimate area, resource usage and cost planning. I have mentioned few concepts and formula used in this type of case study, which states area between two curves can be found by using area is equal to lower limit a upper limit b f of x minus g of x, where fx is greater than equal to gx on the interval a comma b. Find the points of intersection of the two curves to determine the limits of integration. Now this is our first case study, and on the basis of this case study I have designed 5 MCQ as per the board standards, and with the help of which you are going to learn how to tackle such MCQ based on these case studies. So let's move forward and discuss our first question on this case study. So students, here comes our question number first, which states what are the points of intersection of the curve and y is equal to 4. Very simple. What we have to do, we have to simply plug in the value of 4 in this particular equation so that we will get this one, and this implies x equals to plus minus 2. So our option is A is the correct answer here. Very simple. So this is our point of intersection. Now let's move towards question number 2. So students, here comes our question number 2, which states what is the correct integrand for the area between the line and the parabola. So if we draw a graph of this particular problem, then we will get like this: y is equal to x square. Number 1, y is equal to x square, and next one was y is equal to 4. Y is equal to 4. So y is equal to x square will give you parabolic curve which is opening upward, and y is equal to 4. Let us say this is 4 unit. So y is equal to 4 will give you a horizontal line which is parallel to the x-axis. On this particular line the value of y will be 4 only, and our area will be the area defined by the line minus by this particular curve. That means if we use another color for the area which we need to find out, then this will be our required area, and that implies line minus parabolic curve, which implies equation of line is 4 minus x square, and the limit is basically nothing but the point of intersection here, which is minus 2 to 2. So minus 2 to 2. Hence we can say that our option number C is the correct answer here. C, minus 2 to 2, 4 minus x square dx is the correct answer to find the area between the line and the parabola. I hope this concept is clear now. Now let's move towards question number 3. So students, here comes our question number 3, which says what is the value of minus 2 to 2 x square dx. Very simple. Here we are using what? Minus 2 minus a to a fx dx. We can use this particular property which states twice of 0 to a fx dx, right? So we will be getting like this: 0 to 2 x square dx. So integration of x square is what? X square x cube upon 3. Now upper limit is what? 2. Lower limit is 0. We are going to multiply this by 2. Very simple. Now we are going to get our answer by simply plugging the upper limit here, that is 2. So 2 cube upon 3, that means 2 into 2 cube upon 3, that is 2 to the 4 to the 8 to the 16. So 16 over 3 is our correct answer here. So we have option number A, which is the correct answer here. Now let's move towards question number 4. Now student, here comes our question number 4, which states what is the total area enclosed between the curve and the line. That means we need to find this particular area which we have already discussed. Now we need to find what? We need to find this particular area, and this area we are going to find by the integrand minus 2 to 2 4 minus x square, as we have discussed before. Now we need to integrate this only, and with the help of this we can easily find out our answer. So first let's split this particular problem, that is integration of minus 2 to 2 4, then minus of minus 2 to 2 x square dx. Very simple. Clear, students? Now we can simply integrate the first part, that is 4, and integration of this is nothing but 4 into upper limit is 2 and minus 2 we can simply put, right? So 2 minus minus 2 is plus 2. So 2 plus 2 is 4, and 4 4 is 16. So first part, that is first integrand, will give us 16. Now we are going to simplify this integral. Simply this is an even function, therefore we can say that we can use twice of 0 to a fx dx, that is x square. A is what? A is 2. So twice of x cube over 3, as we have already discussed in our previous question. Here we need to simply plug in the value here, and we are going to get nothing but 16 over 3, our answer here. Now we have to subtract 16. We have to subtract 16 minus 16 over 3. Very simple. So this is going to give you 48 minus 16 over 3, that is 8 minus 6 is 2 and 4 minus 1 is 3. So 32 over 3 will be our correct answer, and option number A is our correct answer here, that is 32 over 3. In this manner we can easily find out the area between the line and the given parabola. Now let's move towards question number 5. So here comes our question number 5, which states what property of the integrand can be used to simplify minus 2 to 2 4 minus x square. Obviously we have used the symmetry over y-axis. That means if we have an even function, then we can simply use minus a to a fx dx is equal to twice of 0 to a fx dx. Very simple. So this is the symmetry about the y-axis. So this is not the correct answer, because it is not an odd function property. Symmetry about the y-axis. So students, that was the last question of this case study. I hope you enjoyed this particular video. We are going to discuss more case studies on the chapter application of integral in the coming videos. Also, I have prepared the online test for 1 marker question on different chapters for grade 12 students. That is going to enhance your skill how to tackle 1 marker question in the coming board exam. I am going to share the link in the description box so that you can easily access those online tests, and these tests will be free of cost on our website, which is udgamwelfarefoundation.com. So that was all in this particular video. We are going to meet in our next video. Till then, goodbye and take care.